The next lines, the next 240 lines, give the coordinates and orientations of the remaining 80 trees. And we'll scroll down here to the bottom. Okay, line 265 and line 266. These are basically discretization parameters. The model began with a published model for spheres of uniform foliage density back next to each other in a regular array. If you want to calculate the mean leaf area index that is transited by a solar beam coming to a given location, transiting the crown of the tree itself and the neighboring crowns, you can get an analytical solution. If they're not spheres and so on, then there's no analytical solution. So what I do is numerically step through from the canopy location outward back toward the sun in steps of 0.1 meters, and I stop stepping at 60 meters. You're either out of the canopy or there's so much leaf area in the way that there's zero contribution in that direction. Again, change value is relevant now. Line 268 through and 269 describes the soil and root conditions. Number 7 in my parameterization says it's a clay loam soil type, so that determines the Van Gogten parameters for both water potential and hydraulic conductivity. 8 gives the soil depth in meters, or actually the root zone depth in meters. This is much more than the realistic one. This just makes sure that the water doesn't get depleted when I'm simulating an unstressed canopy. And 0.442 is the saturated volumetric water content for this clay loam soil. I'm starting out with the full water content. Then these values on line 269 describe the root system. It has a total fine root mass of 95 kilograms on this tree. Its volumetric density is 250 grams per liter, or 250 kilograms per cubic meter, meaning it's 1/4 dry mass and 3/4 water, typical. This is the fine root diameter in meters, the mean value of millimeter. And this is the root length density, which actually can be calculated from these other values. And the last item is a clumping factor that was devised by Francois Tardieu and his co-workers. And this is a factor that reduces the effectiveness of roots from completely dispersed roots that don't interfere with each other's water uptake. Okay, line 270 says I'm simulating from an initial date of July 1st to a final date of August 31st, meaning basically all the days that the weather data covers. Line 271 gives the row and column spacing of the trees, which could be computed from the knowledge of all of these coordinates of the 81 trees, but it'd be hard for the program to know which trees are truly neighbors. So in here, you say it's a 9 by 9 meter square array, and that's used to convert from the flux per tree to the flux per ground area. It basically says that the tree covers 81 square meters. Change value again irrelevant. Line 273 says that the main results are going to be put into a file of this name, so you can edit that to whatever you want and try to make it unique for everyone. Remember to go back in here and basically change this infix, is what I've been doing, G, H, I, and so on. Line 274 is a holdover from times when I would rerun simulations with only a difference in, say, Ballberry index or something. I don't use that anymore. Now let's go back up to the top of this file and look at a couple of other control parameters. Very first line, n times histo. That says that the model is going to generate a histogram of all sorts of things, light levels on different leaf area, different values of photosynthetic rate, transpiration rate, and so on, for the 39th different hour of simulation. That means it's hour 15, 3 p.m. on the second day, which would be, in this case, July 2nd. Now, these histograms are extremely informative, so it's nice to have this. Line 2, II info says, give me the maximum number of pieces of information in that results file. If I set it to 1, I would just basically get the hour, the day, the hour, and the 2 fluxes. But if I set it to 2, I get more information. 4 says, give me everything. Well, not quite, because line 3, II info extra, set to 1, says, give me some additional information about the mean values of leaf temperature, internal CO2 level in leaves, etc., somal conductance at every hour on every day. Okay, the last couple parameters here. 30 for the value n bins means that I resolve 30 different discrete light levels between 0 and the maximum. When I'm simulating the different amounts of light intercepted, not only with different light penetration by diffuse light, but also different orientations of the leaf relative to the solar direction. And then these two values, D00 start and I00 start, are used to deconvolve the gross energy flux density recorded with the pyranometer into the PAR and the NIR and the diffuse and direct beam portions. For instance, if the total PAR flux density, taken as about half of total energy density, is below the maximum for that solar elevation, if it were all direct beam, it says, okay, some of it is in diffuse light, and then an elaborate algorithm that developed figures out how to partition that. And then finally, if I didn't already cover this, line 5, F is the fractional change in flux. That indicates convergence of the iterations for the fluxes. I take it as 1%. Okay, so now suppose we have all of the information in the input data file, we have the weather data file, and so on. We execute the code by, well, obviously you have to compile it, but let's say once it's compiled, I will type in the name of the executable, and it has a lot of information that's almost irrelevant. BB standard means I went back to using the standard Ball-Berry model instead of some modifications. And the 19th of August 11 is when the essentially final code was made, but the suffix D says, well, I made a few changes from there. Okay, this will start the model running. Oh no. Okay. Now, the other thing we have to do is type the name of that input data file. So I happen to call it ELP for El Paso, and then data standard. Okay, and then I use the suffix G. Well, it's an infix really. .text. That's where I entered all my values. Now I have an option to add an infix into all the results files so that I know that they go with the input data file G. They were created with all the values in that file. And now it begins to run. So this is quite a fast machine. It's zipping through. So you can see the, well, we can let this whole thing run. It won't take very long. Every day, every hour, it's recording all the fluxes and the values that were also recorded in the final results file, the results underscore RDS, blah, blah. And you can see there's a summary. I can actually pause this. But after each day of simulation, it gives the total amount of water that was transpired through that central tree and converts it into the equivalent millimeters per day on a ground area, and does the same thing for the production of photosynthate. And we have a short ways to go. At the very end, it will do a summary for the entire length of the run. We'll get up here to date 243 in this case. Okay, we're finished. So if you look on the very last lines, it recapitulates what the total leaf area on the tree is. You can also then convert that to a mean leaf area index on the ground area, divide that by 81, you get about 2.6. This is a 70% covered canopy. It means in the crown area projection, it's higher by about 1.4, so almost 4 for a leaf area index. This is the ground area covered by an individual tree, well, dedicated to it, you might say. This is the average light level on all leaf area over all times of the day. It's about 40% of the peak level, obviously. This is, I'm trying to remember, I haven't used these parameters in a while. Anyway, then it gives most relevant thing for me in this study is what was the total water use by the central tree over all the 62 days of the simulation, almost 30,000 liters, and the total kilograms of photosynthate over this time, and by dividing these you get a water use efficiency, which is 3.6 grams of photosynthate per kilogram of water used, and then finally the average control coefficient for stomatal conductance over photosynthesis and transpiration. Obviously it's much greater for transpiration, whereas the stomata comprise the main resistance. And that's basically a summary of this. Okay,